Welcome everyone, and very good afternoon to those of you who are joining in from Europe. Good evening to everyone joining from India, South Asia, and Australia. Both our distinguished speakers are based in Australia at the moment. And good morning to anyone joining in from the US and South America. So today is our 15th and our last seminar of this series, which is on the digital future for business and society, perspectives on AI challenges and opportunities. This seminar series has been hosted jointly by Professor Yogesh Dwivedi. Professor Yogesh Dwivedi is a professor of digital marketing and innovation and the founding director of the Emerging Market Center and co-director of research at the School of Management at Swansea University, Wales, UK. Welcome, Professor Yogesh. You're on mute. Our co-host for the seminar series is Professor Ramkrishnan Raman, who is director of Symbiosis Institute of Business Management, Pune, and our Dean, Faculty of Management at Symbiosis International University. Unfortunately, due to prior engagements, he couldn't make it, but he apologizes to all of you. Our entire seminar series has been supported, very interestingly, by the Center for Technology, Innovation, Management and Enterprise, called TIME for short, the University of Kent, UK, Digital Marketing and Analytics Special Industry Group at the Academy of Marketing, Grenoble Graduate School of Management, the Swansea Innovation Lab at the Swansea University, the E-Business and E-Government Special Industry Group, British Academy of Management, and the UK Academy for Information Systems. To tell you a little bit about the seminar series itself, this has been inspired by various perspectives on artificial intelligence and its transformative potential as presented in a recent perspective article by Dwivedi et al. 2019. AI undoubtedly offers transformative potential for the augmentation and even potential replacement of human tasks and activities within a wide range of industrial, intellectual, and social applications. The pace of change in this AI technological age is quite staggering, with new breakthroughs in algorithmic machine learning and autonomous decision making, creating opportunities for continued innovation. The impact of AI could be significant in industries and sectors across agriculture, finance, healthcare, manufacturing, retail, supply chain, logistics, utilities, all potentially disrupted by the onset of AI technologies. The seminar series on the digital future for business and society will present various perspectives from a number of leading expert speakers to highlight the opportunities and challenges posed by the rapid emergence of AI. Allow me now to introduce our two distinguished speakers for today. Dr. Shahriar Akter is an associate professor of marketing analytics and innovation at the School of Business at the University of Wollongong. He was awarded his PhD from the UNSW Business School Australia with a doctoral fellowship in research methods from the University of Oxford. He has published in leading business journals, 40 plus A or A plus ranked articles in the ABDC list with 90 plus total publications. He is one of the top 2% business analytics researchers across the world, according to the 2020 Stanford University Ranking. His current H index is 28 with 6,000 plus citations in the last 5 years. He is a visiting professor of the Toulouse Business School in France, the University of Michigan, and Shanghai Jiao Tong University Joint Institute, China, and the Karlstad Business School, Sweden. Our second distinguished speaker for today, Dr. Katina Michael, is professor at Arizona State University, holding a joint appointment in the School for the Future of Innovation in Society and School of Computing, Informatics, and Decision Systems Engineering. She is also the director of the Society Policy Engineering Collective, SPEC for short, and the founding editor-in-chief of the IEEE Transactions on Technology and Society. Dr. Katina is a senior member of the IEEE and a public interest technology advocate who studies the social implications of technology. Today, Dr. Shahriar and Dr. Katina will be speaking about addressing algorithm bias in AI-driven customer management. So with those words of introduction, I would now like to hand over the floor to Dr. Katina and Dr. Shahriar. Over to you both.
Shall I go first, Katina, to start the presentation? All right, great. Okay, so let's get started with the presentation. So today we are going to present algorithmic bias in the age of AI. And as you know, my name is Shahriar Akter, and you can call me Shah. So in this presentation, I'm going to focus on basically three things. What is algorithmic bias, sources of bias, and Australia's robot date, a case study, which will be presented by Professor Katina Michael. Before I jump into my presentation, I would like to say that whatever I will be presenting, these are based on our recent research. We are writing few papers together, Professor Katina, Professor Yogesh, and I, as co-authors. We are basically writing papers on algorithmic bias, and today we are going to shed some light on our findings. Well, first of all, I would like to start with the Industrial Revolution. So the first Industrial Revolution, if we look at, it was based on steam engine and coal power. And that was the first revolution the world has seen to transform our society. And it was the beginning of the civilization as well in terms of industrialization. The second Industrial Revolution started with electricity. And we went to mass production with the help of electricity. And that was the second Industrial Revolution. In the third revolution, we focused on computers and digital technologies. And that has transformed our banking, our energy sector, and it has given us a lot of productivity with the help of digitalization. In recent times, we are experiencing the fourth Industrial Revolution, and the core technology that is transforming this Industry 4.0 is AI, or artificial intelligence. In addition, we have got few other technologies in Industry 4.0, for example, cloud, IoT, data analytics, blockchain, robotics, 3D printing. But at the forefront is AI. Now, what is AI? Before we jump into our algorithmic decision-making, algorithms and its bias, we need to understand what is basically AI. Well, AI, this term was introduced by John McCarthy of Stanford University back in 1954 in the Dartmouth Conference. And John McCarthy was one of the founding fathers of artificial intelligence. You would be surprised to know that he was also giving the initial ideas for cloud computing and self-driving cars. So we can also say he was one of the founding fathers of cloud and self-driving cars in addition to artificial intelligence. John McCarthy defines AI as the science and engineering of making intelligent machines. When John McCarthy was developing AI in the US, on the other side of Atlantic, Alan Turing was developing his Turing machines. And that machine was responsible for breaking all the codes during the Second World War. But Alan Turing's AI-related research didn't get out because of the Official Secrecy Act. So we can say most of his findings were hidden because of that act. So both these great scholars, Professor McCarthy and Alan Turing, both are basically the founding fathers of artificial intelligence, in addition to some other founding fathers. For example, we have got all these names who have joined in the 1956 Dartmouth Conference. Having said that, this artificial intelligence, in the early stage of artificial intelligence, how did it work? Well, the first generation programming, it worked like recipe. You do this, you do that, and then the magic happened. For example, some output is coming out. But that we have moved from that first generation programming to second generation programming, and that programming has been possible due to the massive rise of big data. So if we look at big data, you look at every single minute, we have got all these different type of logging, 700,000 logs in Facebook, Netflix movie hours, the Google received 2.4 million search queries, the mighty Amazon makes $200,000 per minute. So all these digital platforms are creating lots and lots of data. And that has given the rise, the hype of second generation programming, which is based on data. And what we do in this type of programming, we basically feed lots and lots of data to a machine. We ask the machine to digest this data, to classify this data, and predict an outcome. So there is no hardcore coding involved in this second generation programming. Now, with the help of this second generation programming, we have got two types of artificial intelligence based techniques. One is machine learning, and we define machine learning is the ability to learn without being explicitly programmed, because most of these machine learning algorithms is based on, basically we are training a machine to predict the outcome. We ask machines to learn from the data and predict the outcome. And this another type, which is deep learning. And when the data size is huge, the volume is huge, we ask the machine to act like humans and apply deep neural networks to predict the outcome. In both cases, there are some differences between these two types of AI-based decision-making. In case of machine learning, it's still the human involved. The human is basically finding out the most important variables. And based on the variables, we ask machine to identify which variable is the most important, for example, in buying a car. And we apply different types of algorithm. The simple algorithm is factor analysis, for example, or cluster analysis. These are machine learning based algorithms, supervised machine learning based algorithms based on the variables set by human. And the other one is deep learning, where we ask the machine to learn from the data to identify which variables are most important automatically and classify them to predict the outcome. So these are the two techniques we basically apply in the AI-based decision-making or algorithmic decision-making. Now, throughout this whole process, if we basically synthesize or summarize the whole process of decision-making, we can see that it starts with training data, and then we are identifying the variables, we develop the model, we train the model, and then we ask to classify the objects, and then these reports or findings are presented to people. So this is the whole process of algorithmic decision-making, whether we apply ML, machine learning, or whether we apply deep learning. For example, for simple demonstration, I'm going to show you how does this simple machine learning algorithm works. For example, I have 4 variables: class, that means the type of products; cost, the unit price; promotion is another variable, the amount of money you spend on promotion; and your revenue before the promotion. With these 4 variables, the outcome we are going to predict is revenue increase. Which variables are more responsible for increasing revenue? So as part of this, I'm just going into my neural networks, what I have developed today for you using IBM Watson. So let's go into my neural networks, a simple neural networks. So this is my simple neural networks, what I have developed for you. as part of this lecture. So I am asking my neural networks to run the model using those 4 variables to predict which variables is going to responsible for this revenue increase, right? So I am running the model now. So model is run. Now, if I take a look at my results, then results is saying that, I hope you can see my results. So the results is saying that the most important variable is type of product. The second most important variable is promotion. The third most important variable is price. Okay, so now I am taking the results in terms of neural networks. I'm taking the results in my PowerPoint to discuss it a little bit. So let's go back to my PowerPoint. So here is the results of my simple neural network. And here you see the thickness of the node is representing the coefficient. For example, class is the most important variable. So thickness of this node is basically saying it's the most important variable. We call it synaptic weight in neural networks. Promotion is the next important variable. And the third most important variable is price. Okay, now these are the variables that is predicting revenue increase. But what is wrong with this neural network? What is it a right neural network, or is it correctly predicting the outcome? Well, there are some issues with this neural network. Now, if I go back to a quote in The Guardian, all the neural networks might be said to write their own programs. They do so towards goals set by humans. For example, I have asked these neural networks to predict revenue increase using data collected for human purposes. Now, the keyword here, please look at these keywords. If the data is skewed, even by accident, the computers will amplify injustice. Now, there might be inadequate data. There might be, my data might not represent my population. My data might have some issues regarding misidentification of variables. Or in the model, I may have forgotten to include some other important variables. So if it happens, the whole outcome would be problematic and it will amplify injustice, right? So that is the problem of this algorithmic decision making. Now, if I look back again at my decision making, here you see training data are collected, so bias can happen in the data. Model is developed. I have developed a model, so bias can be hidden in the model. And when I'm classifying, bias can be there. And when I'm interpreting my findings, it can be there. So based on our research, we have defined this algorithmic bias as an unjust, unfair, or prejudicial treatment of people related to race, income, sexual orientation, religion, gender, and other characteristics historically associated with discrimination and marginalization as part of this algorithmic decision making. So there might be unjust outcome, unfair outcome, prejudicial treatment, and Professor Katina Michael will today discuss a classic case of this algorithmic decision making bias. That is a very, very well discussed case in Australia, and I hope you'll enjoy that case. Now, based on our research, Professor Yogesh Dwivedi, Professor Katina, and I are directly involved in this research. We have found that there are 3 sources of bias. The first source is data bias. Sorry. The first source is data bias. The second source is model bias. The third source is social bias. Now, with regard to data bias, we might have different sorts of data bias. So here you see the first bias is sample bias. If we collect data from a population and that population is not our target population, then we call it selection bias. If we collect data from another type of population which is not relevant to our target population, we call it outgroup homogeneity bias. For example, the research is on dogs. If we collect data from cats, then we call it outgroup homogeneity bias because both samples are different. The sample size is not adequate. If we do not have enough sample, if we do not have large amount of data, deep learning or neural networks do not predict the correct outcome. In case of model bias, we can have model, in case of model related bias, for example, I have developed a simple neural network for you for today's session. Overgeneralization bias. For example, the COVID-19 spread prediction. If the model is developed in Johns Hopkins, and if that same model is applied in India or Bangladesh, the problem is the context is different. That model has to be readjusted. All the parameters has to be readjusted. So we call it overgeneralization bias. If a model is developed by data scientists in UK, and if that model is applied in Australia, it doesn't work. Correlation fallacy, we call it correlation is not, that means causation and correlation, there is a difference. Correlation is not causation. If we run a neural network, every variable is correlated with every variable, but we need to find out what is the insights. We cannot make decisions just because they are correlated. Confirmation bias, we tend to confirm our own beliefs. That's a problem in data science, and that is a problem in algorithmic decision making too. We try to confirm our beliefs, our own agenda. Automation bias, we believe that what is being churned out by a machine, that is superior. We try to make our decision more on a coefficient rather than on reality. So that automation has to be justified. That automation related findings has to be justified. And then we have got very interesting social or people related bias. For example, stereotypical bias. And as part of stereotypical bias, in South Asia, we have got a stereotypical bias that women are not suitable for STEM jobs, science, technology, engineering, and math jobs. For a long time, we have had this stereotypical bias. And that's why all the tech companies, when they recruit someone, they tend to focus on male applicants rather than female applicants. And Amazon's recruitment system has been recently accused of this type of bias. Historical bias, for example, is related to racial bias. For example, a Black American is more responsible for aggressive behaviors, and that's why they are not suitable for some particular type of jobs. And that has over and over, that has been identified in different research, which we can identify as historical bias. Implicit associations, for example, women employees or female employees receive low salaries for the same type of job rather than male employees. So this type of implicit associations are reflected in algorithms, and different types of social prejudices, because all these algorithms are being made by humans. And in that particular group of data scientists, if we have a specific group of data scientists, they have got social prejudices very high, then that might be reflected in the algorithms. So all these sources of bias have to be mitigated. They have to be addressed when we develop algorithms for customer management. Now, in our research, we have come up with some ways to address this bias. Because of the time constraint, I'm not going into the depth of these mitigation strategies. Our research will be out very soon, and I'm happy to forward our research paper for reading. But in a nutshell, we have come up with 4 ways to mitigate bias a priori. before happening bias, we can make our algorithm robust if we can embrace scientific consistency. That means algorithm is scientifically strong and it is robust and it is audited over and over. Then we can address this bias. Application consistency, the algorithm, when it is tested on training data, testing data, validation data, every time it is giving the same consistent results. Stakeholder consistency, when we develop an algorithm, we can consult with all the relevant stakeholders. For example, if it is for COVID-19, we can discuss with hospital employees, nurses, frontline employees, doctors, physicians, and general people to see whether this algorithm can predict the reality. Assurance consistency, if something goes wrong, who will be responsible? Is there any sort of assurance that the data privacy, the data security, information, all will be maintained? So that type of assurance consistency has to be there before anything goes wrong. Now, if something happens, for example, the algorithm bias has created a lot of problem in the society. For example, we have seen Facebook has abandoned its algorithm of facial recognition. Amazon has abandoned its algorithm on recruitment. Google has abandoned its algorithm on image recognition or some sorts of self-driving cars. Now, all the big companies are abandoning their algorithms because those algorithms have got a lot of issues. Now, once the problem happens, then what should you do? Well, in our research, we have said there are 6 ways, 6 steps to address if any particular problem happens. Identify the problem, review or audit extent findings regarding the problem, what other algorithms are doing in other countries or other contexts, how this algorithm is being applied, fixing relevant variables. Can we address gender, or can we address the particular type of age so that it doesn't give us biased outcome? Ethical and responsible model. So nowadays we are talking a lot about explainable AI, because all these days we have developed AI model and we say AI model has got a black box. So can we turn that black box into a glass box so that we can see what is happening in the model? Can we show all the variables, how they are being plugged in? Training data. So data quality has to be very good, and we have to make sure that training data, test data, validation data are working well. And finally, we have to act on insights and improve the model based on stakeholders' feedback. So stakeholders have to be involved. If it is for customers, we have to involve customers. We have to involve all the regulatory agencies or people who are responsible if anything goes wrong. And we have to take care of the laws and regulations. For example, Europe has got GDPR, or General Data Protection Regulation. So we have to involve the stakeholders in order to address any issues relating to this algorithmic bias. So that's all from me. And thank you very much for your patient listening. At this stage, I would like to move the floor to Professor Katrina Michael. Katrina, it is all yours now. Thank you.
Thank you so much, Shah. It is wonderful to be presenting alongside my colleague and collaborator from the University of Wollongong, someone I admire greatly, and I appreciate the positioning of this comprehensive introduction and main thesis of our paper. This section of the talk will look at whether it is algorithmic bias or algorithms out of control. And as Shah said, I will be honing in and focusing on perhaps the most scandalous AI case study the world has ever seen, although there are quite a few competing AI scandals. This one has been dubbed by the media robo-debt. In this part of the presentation, I will be talking to you about the agency that is responsible for Centrelink services and its respective customer base. I'll be looking at specifics, the present mode of operation to the future mode of operation of robo-debt, what changed between 2017 and after 2017, what was the fallout from robo-debt, specifically the unintended consequences and the human impact, and finally, a brief analysis and recommendations going forward. So about Services Australia, who is in charge of the automated bot. Services Australia looks after Australians by citizenship, and they deliver social security payments and services to its eligible customers. And it's quite a strange thing to talk about citizens as customers, but in this case, they are customers of this government agency. Centrelink distributes payments to specific groups of people: retirees who get a pension, the unemployed who require ongoing benefits to supplement their existence and their payments, families, carers and parents who get some rebates, people with disabilities that may be on a short-term or long-term pension, Indigenous Australians for particular reasons, students who are studying perhaps, and students who are in high school and primary school, if their parents are under a particular income threshold, apprentices who are trying to develop a vocation in an area, and people from diverse cultural and linguistic backgrounds. So Service Australia services perhaps up to 150 different language backgrounds. And we see here on the portal website that you could visit on MyGov that there are pictures of care, two people together discussing their eligibility perhaps, one a government employee and the other seeking payment or seeking some support. And we see the smiling face. We care for your well-being, and of course reciprocated by the citizen there saying thank you. But if we look at top, you can see this sign-in function, which has emerged over the last 10 years. It's digital online support, and that enables somebody to actually have access anywhere, anytime. But the transformation we're going under is really not about being together with a government employee, but this is really a form of perhaps unpaid citizen work, this notion of self-service. Please, go to mygov.au and sign in and self-service your way through what you require, download relevant information, check your income levels and other asset testing means, and then proceed. But this self-service notion that has come about because of e-business around the 2000 mark has now been propelled forward to do more than just download information. We have these new different online models of which governments are slowly transforming towards. And what we see here, if we hover long enough on the Centrelink website, is that you'll see a pop-up digital assistant that says, hello, I'm Service Australia's digital assistant. No longer the smiling face next to the actual physical person, but actually a bot that is asking you to ask a question. And so this transference, this same kind of feeling that customers perhaps expected in the physical space is not exactly what is being greeted by when they enter the online world. And here we see in the fine print of this digital assistant, don't type any of your personal details to find out how I use what you tell me, type privacy. And so all of a sudden this word privacy may perhaps render someone to think about trust, whether they trust entering information or seeking information on this online digital assistant. It's raising awareness perhaps, but it's not human. And most customers would understand that this assistant is actually bot driven, but it's education on the fly. I can answer general questions about payments and services. How can I help you? Please type in and I will reply to you. But there's no real training. The training is happening on the fly. And citizens at that point can figure out whether they wish to opt in or opt out. And here what we find during the pandemic, we had a lot of people lining up for unemployment benefits outside physical Centrelink buildings. And this government agency was frequented by so many people. Some of the media had commented, we hadn't seen that many people queuing since the Great Depression, perhaps an exaggeration, perhaps not. But of course, the coronavirus ended up being a huge intervention. And what we found was that the digital systems failed. That's one reason that people started to queue up, even though they were supposed to digitally and physically distance themselves from one another. And people flocked back to the original model, the bricks and mortar model, the model that says, I want to talk to someone because if I don't get my benefits, I'm not going to be in a home. I'm not going to have food to eat. So it was help. And this is when we started to realize that people matter. We cannot extinguish our workforces from serving customers. We cannot completely rely on the online world because we may need to revert as a contingency back to the old bricks and mortar model, not just clicks and bricks, or clicks and mortar, I should say. So if we ponder into the case study a bit more, what we'll find is that we're dealing with a socio-technical system, and our customers are either eligible for payments or they are not. Some of our customers may be dubious. They may be putting in false claims, fraudulent claims, using similar numbers as somebody else, perhaps a tax file number. They may be making false claims on behalf of an employer. Who knows? But for the greater part, most people tell the truth. If we look at the technical aspect of the socio-technical system, we can see that payments are no longer done using the old methodology. You would turn up to the bricks and mortar agency, you would receive your payment, there'd be a cross-check, you'd show your ID and you'd receive your benefits. But in fact now, because of automation and the fact that e-payments are on the rise, much greater than any cash payments, there is a lot of convenience with going this way. There is also the establishment of the Human Services Centrelink Act in 1997. That was established particularly when we were near the tax file number that was introduced a bit earlier. And what we had was this automation occurring. And of course, the introduction of data matching. So what we had is the ability to detect false claims through data matching processes. But those data matching processes had a human in the loop. There was none of this automatically sending out debt collection letters accusing people of having made false claims or fraudulent claims. But in this ecosystem, what we see, bounded by the shores of Australia, what we have is a closed Australian system. Everyone outside perhaps were aliens, they were visiting to Australia, perhaps they weren't citizens and were not eligible for any benefits whatsoever. Also, there are other social security systems across the world, but these were outside the actual system that we are currently interrogating in this presentation. Now, all this happened before 2017. And what we had around that time, in July of 2017, our Social Services Minister, who happened to be the current Prime Minister, Scott Morrison, announced the Online Compliance Intervention System. And this was supposed to automate debt assessment and recovery. This was supposed to be an efficient way of identifying people who had made fraudulent claims or had asked for more money than they were eligible. And this was about recovering these monies automatically. And the scheme aimed to replace the formerly somewhat manual system of calculating overpayments and issuing debt notices to welfare recipients. By December of that year, it was announced that the Online Compliance Intervention System would go live in 2017. And what we then had was the automated data matching system that compared Centrelink records with averaged income data from the Australian Taxation Office. And that word, averaged income data, is something that we will return to. So Shah talked about three things in terms of bias in algorithms: the data, the model, and the social side. And here we have something to do with the data and the model. The future mode of operation, where you can see AI at the center of this somewhat complex Venn diagram, everything is exactly the same, except there is no more human intervention. The AI has replaced the function that was manually done before. So in our digital transformation thinking as a government agency, we are thinking, okay, we are at the point now where we have been doing data matching since the introduction of the tax file number in Australia, in the Australian Tax Office. We now have e-payment schemes. We are distributing monies electronically. We have some form of automation when we are scrutinizing our data for potential readiness to compare against claims made. And now we can perhaps come of age. Shah showed us the different introductions of the Industrial Revolution, or the phases of revolution. And I'd say we have moved, in this case, in the future mode of operation, from layers 3 to 4 into the cyber physical social systems, this I4 layer. So the AI completely replaces the human in the middle. So the human is out of the loop in this complex data matching process. Around about the time, maybe 3 or 4 months after the online compliance intervention scheme was launched, we had a few queries. The government was collecting debts, and people were starting to say, but I never made a mistake, and I never claimed this, or I never claimed that. The Commonwealth Ombudsman investigation in this sort of environmental segment, if we look again at the socio-technical, what I want to say here is we just don't have the social side and the technical side, but we have an environment that allows the socio-technical to operate within. And this was overseen by the legislation, the Human Services Centrelink Act. But what we are talking about is going beyond. If there is an error or there is an interruption or disruption to this beautiful socio-technical future mode of operation, then there are ways to actually combat that through investigations and Senate committee inquiries, depending on your political and economic system. So what we found was in the Commonwealth Ombudsman investigation that the Department of Human Services should have undertaken a more comprehensive evaluation of the scheme in its current form and give further consideration as to how to mitigate the risk of possible over-recovery of debts. You'd have to think that one of the scenarios implicit in this case study was the potential risk of either not claiming enough monies or claiming too much. Debts based on averaged Australian Tax Office income may be less accurate than debts based on actual income, full-time assumed. And so the government agency made a mistake. If people said they worked 10 hours, 35 hours, what was being claimed was a partial mismatch. So if you work 7 hours, then definitely you were part-time with the propensity to work more. And if you were 35 hours, you were full-time. And these assessments were done based on these high-level numbers, not actual income levels. And at the beginning of a period, I think the government agency underestimated how many people work part-time and opt to take additional hours or less hours, depending on how busy they are in a given time frame. There was also a lack of clear communications over the debt. The reason for the debt notice was never explained to the individuals receiving the debt. So you can imagine getting a letter at home, opening it up, and it's saying that, you know, you owe the government money, and it not stating why you owed the government money and where the actual issue was in the claim. We then moved to the first Senate committee inquiry, and we saw a response from that Senate committee saying there was a lack of procedural fairness. Fairness is something we hear about time and time again with respect to AI. And finally, the second Senate committee inquiry questioned the former head of Services Australia around 2018, and they said they had never heard of robo-debt. And this is when we start to think about accountability. So the ministers and public servants should have known the method of taxation income records to estimate welfare recipients' average income was flawed. So we know that the process was flawed. We can talk about a flaw in the model itself, as Shah alluded to earlier, and that was the Chief Justice who handed down that report. Robo-debt was a massive failure of public administration of Australia's social security scheme. Again, this was only handed down 4 days ago, so I'm very grateful that the hearing happened before this presentation, but a massive failure of public administration. So what was the fallout of robo-debt? Who pays for government mistakes? Well, the taxpayer, of course. It's public money. So on the one hand, it was the taxpayer who paid for the introduction of robo-debt. And on the other hand, it was the taxpayer again who paid for the mistakes of robo-debt. And so the settlement's worth was $1.8 billion for people wrongly pursued by the federal government's robo-debt scheme. I'm going to say that again, $1.8 billion for people wrongly pursued. The Commonwealth had unlawfully raised $1.73 billion in debts against 433,000 people. So 433,000, almost 500,000 people received envelopes with a debt collection notice that was wrong. You would have to think that after the first 3 months, they would have learnt from their mistakes and would have ceased rolling out these rolling letters over time with these debt notices. And so this was unlawful to actually enter into such a scheme to begin with, and I'll explain about that in a few minutes. We also had $8.4 million going to Gordon Legal for the class action lawsuit. The company, the legal firm that represented all these people who had received debt notices, and that was brought against the government on a no-win, no-fee basis. But because the class action lawsuit won, $8.4 million went to Gordon Legal for representing all those people. So AI errors, if we are to learn anything from this presentation, AI errors are asymmetric on humans. Okay, we are talking about a public system, but it had personal repercussions. And robo-debt was supposed to be a public good to catch those making fraudulent claims, costing other taxpayers money, but instead this public good caused personal harm. Technology errors have a human toll. Technology is not neutral, and the humans behind the technology need to be held accountable. Perhaps that last sentence is a little harsh, but we'll see why it becomes more sensitive as we go through the presentation. The unintended consequences of robo-debt included financial hardship, anxiety and distress, suicidal ideation, and in some cases confirmed suicide. Many who received the letters said they felt shame and hurt by their government. They were wrongly branded welfare cheats, and it affected more than just the 1.7% of Australians. So we have 25 million people in Australia, almost 500,000 were accused of fraudulent claims. But it wasn't just the 1.7% that actually suffered at the hands of robo-debt, it was all the families who saw those who suffered as well. But the heaviest toll was felt by the vulnerable people. And Shah mentioned this notion of discrimination against minority groups, those who were unemployed, those who were on disability payments, those who could not afford basic energy or grocery bills, and those who were at risk of their loss of housing. And so my analysis tells me we need to bring the worker back into the loop. Human-robot interactions are socio-technical bidirectional flows. We just don't have robots replacing humans when we are transferring through this digital transformation. And the flows are bidirectional, so there is some kind of handshaking and cross-checking when it comes to severe things like debt notices and accusations. And somewhere on this spectrum, we see the new type of socio-technical system that's emerging, not so much social perhaps, but impacting the social, because maybe it's a robo-technical system instead of being a socio-technical system. And so how much of AI will emerge to overtake that human element, both as end user customer and perhaps employee in the government? And so on this sort of linear scale, I've placed a triangle of where robo-debt was sitting, somewhere more towards the robots. And what we want to see is a shift to some kind of sharing. The robots and the calculations and the automation does what it does best. And the humans are there to cross-check perhaps periodically, not perhaps every single claim, if they can see a pattern of positive change. but there is what humans can do better, perhaps, and what robots can do better. It's developing better lawful socio-technical systems. Here, what we don't know yet, and was not clearly identified by the justice, was that possibly the whole scheme was unlawful to begin with. Customers, citizens of Australia were not told that their data would be collected for tax purposes and used the way it was. So did we have the consent of the constituency? And the answer is no. But rather than being a conspiracy theorist, what we are basically saying is lesson learned, this will never happen again in Australia's history. So we need to better design and better test our socio-technical systems, our next-gen socio-technical systems, and we need better regulation to support the end user. We need to build the business case for training and citizen engagement. We shouldn't be going to a portal and for the first time being trained on the fly. Where are these communities and community centers and libraries that could support us in bringing us forward as citizens to a digital transformation? And of course, the employees likely need more training about legalities and the environment aspect of the socio-technical system and ecosystem. So we may need to optimize tasks to distribute them, deeper investigations, better record keeping, more accurate income assessments. Bricks and mortar are certainly not dead. How do we replicate this as a contingency with the online world? How do we work together between physical and cyberspaces? Computers calculate better than humans, but what kind of models are we feeding them? What kind of data are we feeding them? And what kind of social expectations do we have when people fill out their incomes test? Data matching of records has been happening for many years, decades in fact, but what kind of data matching is happening at this point? Citizen consent. Friction is not a bad thing all the time. Friction could be good to identifying issues early on in the testing phase of a new system, and we shouldn't solely rely on machine learning. We also need to better anticipate extreme and exceptional AI-based scenarios. Gone are the days where we can say, this will never happen, this will never happen. We can see this with the Uber tragedies in Arizona in May of 2018, where a training driver lost their life. Here we could do scenario planning. What's the worst case? We could do a conflict of interest scenario. Was Centrelink, was Services Australia in conflict with its own interests? On the one hand, giving out benefits to people to help them live, and on the other saying, oh, I think we may collaborate with the Australian Tax Office and use disparate workflows and systems internally to the government to find out whether someone's telling the truth or not. And this is an internal conflict of interest. There is actually legislation that deters people from engaging in this kind of behavior. And better regulatory systems, better contingencies where we use AI, and better internal policies in the government. So human training is essential for building a workforce that can identify, intervene, and interrupt flawed flows. If we notice something early, stop it, correct it, and then perhaps begin again. So to finish here, a socio-technical legal system, I'm pretty sure it wasn't the law that failed us, it wasn't society that failed us, it was the technical side quite clearly. What kind of software quality assurance do we have? And it's time to educate our programmers, our business information specialists, that when they configure systems to abide by a brief and they translate this brief into formal language through software, that they need to ask themselves if what they are doing is actually legal. It's not enough to have good programming skills. You need to be asking yourself about the legalities and the ethicality of a particular system. If only one person had raised the alarm bells to say, this is not going to work, possibly we're not asking the right questions, we would have solved this heartache a lot sooner. The other question is, did anyone go to jail for the suicide of innocent people? There's an absence of evidence and proof, but we are now saying that in the hundreds, people committed suicide. One figure on ABC's Triple J said it was possibly 633 vulnerable people that were abuse victims or mental health, those living with mental health that actually suicided, 633. But there's only one evidence base that I was able to find. So I will just say, I know there were hundreds, but we don't know exactly how many. And of course, given comorbidity, you don't know if it was because of these outlandish debt collection claims that individuals took seriously. So how do you regain the people's trust with respect to AI? And I leave you with this final statement. AI in the workflow is a multi-dimensional issue that requires a multi-dimensional solution, and it has to be done in concert with humans. Thank you.
Thank you very much indeed. And that was a very nice format of Dr. Shahriar and Dr. Katina presenting two different facets and a very, very lucid narrative. And I also think it's the first time in our seminar series that our researchers have actually presented a case study, which is very current and very recent. So thank you very much indeed for both those talks. We have Professor Yogesh with us. Professor Yogesh, your thoughts?
First, big thank you to both Professor Katina Michael and Shahriar Akter. What a wonderful talk. And it reminded me when I was doing my master's, reading all those big failures. And I think UK and Australia is a wonderful in coming up with lots of these great failures. So I remember, in Australia, Man Data project, I'm not sure if you're aware of or not, Man Data project, I think it continued for 3 decades, and they spent millions and millions, and ultimately it was aborted. The project was aborted. It never got implemented. Same thing in UK. We had this Last Cat project, London Ambulance Service, and they designed this wonderful system, and the day they implemented, more than 100 people died because of the system failure. System was doing what it was designed to do, but it wasn't designed to do it properly. So basically, ambulances didn't reach to the places where they're supposed to reach. Therefore, patient couldn't reach to hospital and they died. So, I mean, this looks quite similar in that sense that these projects, actually how ill thought these projects are. And more I'm learning and more I'm listening about AI, I just feel that AI is a kind of mirror. It's a mirror to show how much biases we have as a human, which was not seen before, but it's now amplified. Because, when we as a human make error, it could be sorted on lower scale and it never get seen. But when these systems create these errors, huge number of people are impacted, like you mentioned in this case, 600 people probably took their life because of the error. And it just simply shows that these, things that we have, if we don't actually fix them before we design those systems, then these kind of problems going to happen again and again. Shahriar mentioned Google, Facebook, all these big companies withdrawn their algorithm before any damage caused. But unfortunately, when systems are implemented at low scale, or by public sector and other organizations, then they don't look at, they don't test in that robust way. If the testing was done for this system properly, I'm sure they would have picked up some aspects of these errors, but they didn't, obviously. And you precisely said, that these programmers, ethics also comes here, who are actually involved in designing these systems, how open they are, how well they're actually capturing the requirement, because that's where the problem is. If they capture the requirement well, they actually created the flow well, they actually looked at the regulations, that if their systems or output going to meet the regulatory requirement, then probably this would not have happened. So it's very complex. Like I'm not sure the way we are moving. Actually, the way the AI development is happening is very quick. Now, I would say in this last phase is very quick. Everyone implementing without knowing the data issue, the model issue, or other sorts of issue. Forget the social and other sorts of things. So I guess I'm sorry, I don't want to really go on about it, but it's just so fascinating case you presented, both of you, that I think this is wonderful ending of the first season of our digital future seminar series. It just shows that these systems that have been created, how threatening, how harmful they can be if they're not designed well and if they're not tested well going forward. Yeah, thank you so much. I guess now someone else if like to ask questions.
So the money part is one thing, and the question that begs itself is with all this wonderful automation and AI, one would hope that we are saving billions of dollars, but here we ended out spending $1.8 billion extra. But more important is the loss of lives. I think that is something that cannot be quantified by money. I mean, for money, we might have insurance schemes and third-party indemnity assurances, etc. But human lives, we can't put a monetary value on that at all. So that aspect is probably something for us to consider very, very deeply. And the other aspect from an IT perspective of the AI, a lot of the development is actually given in terms of contracts to companies, where those employees no longer have the wherewithal to question the work that their employer has given them. And that's probably that ethical bias angle that also creeps in, that does the employee even have a way to say, hey, I think this is wrong, can we do this slightly better? I can see one hand has gone up from Mohammad Waliur Rahman. Yes, Mohammad, do you have a question or an observation? Please go ahead. You can type it in the chat box, or you can unmute and speak if you like.
Thank you very much for giving me a chance. Can you hear me?
Yes, we can.
Yes.
Okay, thank you. Thank you, Professor Shahriar Akter and Professor Katrina Michel, for your wonderful presentation. And a special thanks to Shahriar Akter for inviting me to join in this seminar. It was very pleasant experience to know about these things. Actually, I'm from a computer science background, and I think most of you are from business background. But looking at you, and you are employing and talking about this AI thing is very surprising. And what can I say? It's really wonderful to see such kind of research going on all over the world. And talking about the AI, what my feeling is until now we were like looking at this thing as a like as a black box, that what is happening inside, sometimes we cannot explain those things. So AI, or say a deep learning model, you until now we were like considering it like whatever the mathematics are behind, we put them aside, and then we giving these inputs and getting a very good and better output than any other algorithms or any other methods. So people were very interested in this AI and in this machine learning things. But now we can see that there are some light, like you can new researches are coming up, like interpretable machine learning. That is a new movement of like how you can interpret those machine learning things, why machine learning algorithms are giving you such a result, what results is given. So I think that in the future we will have a good AI system, good machine learning system that may not give this kind of fatal consequences. So this was just my observations. And mostly I wanted to thank Shahriar and Katina for their wonderful presentation. Thank you very much.
Thank you. Thank you. Any last thoughts, Professor Shahriar, Professor Katina? It's top of the hour, but just wanted to ask any closing comments.
Can I add
Please,
something to this comment, which was very relevant, obviously. You know, although progress is happening towards making machine learning interpretable, but again, machine will explain that this is why it's making that decision. But if human is not looking at that explanation, how that going to help? As Katina mentioned, that this balance between robo and human, and if little bit this thing need to go towards human, so that human actually looking at things at interval. And if they did, in this particular case, very clearly shows that if they did look at this, what is happening, if there is some problem, then probably they could have stopped it much earlier, but they didn't actually. So even if the machine is being able to explain why you know, these kind of decision is made, is still, I think, human involvement is paramount. I mean, you cannot ignore that aspect.
True.
And yes, I mean, some kind of systems has this little ability, but I think it will take long when we have machines that are fully explainable. I think it will take many years when we will have a robust system like that. Until then, I think human involvement and human input definitely one thing that is very, very important, that human involvement is fully embedded within the robo system. Otherwise, we will see several such cases happening. So yeah, I hope this case you both will present in some nice papers in IS area, so that more and more get to know about it, and probably this kind of its implications filtered through to various people, be it in government or private organizations. It will be really fascinating one to publish, actually.
Yes, I agree with Professor Yogesh in this case, because back in 1970s, when computers were invented, we thought that computers will take over all our jobs, and it didn't happen actually. Computers increased the amount of jobs, and computers is now being augmented by humans, and we have got more jobs, more computers. Similarly with AI, which is going to augment human capability. So we are not saying it's machine's era, we are saying that it's machine plus human's era. So machine plus human will work together, and it will augment capabilities definitely for human. It will increase our creativity as well. It will increase our thinking as well. So machine is not going to replace anyway what we do. So human plus machine. This is the time of human plus machine.
True, absolutely. And I think the use cases need to be very carefully thought through, and those outcomes need to be judged as to what is being delivered. And sometimes one even wonders that what methods for programming are going into actually programming the AI. Because if a human being has a certain bias, is the programming taking that bias into the actual program code, or are we kind of eliminating that? And then how will that work in a real life scenario? So that entire use case needs to possibly be carefully not just thought through, but tested with all kinds of POCs, especially where human lives get impacted and get involved. It's one thing to carry out the docking of a space module with the space station, because those computations are millions per second, which no human being can actually compute. That's one aspect, but here we are talking about human lives being impacted, which is probably a huge impact. So lots of thoughts for future research, I think, for all good researchers.
Precisely, I think Katina mentioned about scenario. have they thought through various scenarios? They clearly not. I mean, this example you mentioned about Uber trainee driver, have they thought through? So they not really, and that's where actually, and also I think the classic problem is generally they want to implement these kind of systems very quickly. They want to design quickly, implement quickly. Agile. So they don't even have enough time to do those kind of scenario testing and scenario planning. And that's where another thing that, look, the previous IT systems were okay. They were probably not that harmful in the sense that even if they did something wrong, the impact would not have been to this magnitude. But now these AI systems can actually be devastating. So more time should be given to kind of, conceiving these systems, designing these systems, testing these systems, and then implementing. So I think that's another area along with training and skill development that require from user side.
True. There are a couple of more hands going up. Professor Katina, Professor Shahriar, do we have few minutes extra time to listen to them? Okay, I can see them nodding. So Sheikh Asadullah, what would you like to share or ask?
Yes, thank you so much. Basically, I would like to just take the floor for giving the thanks, basically, especially to the organizer like Professor Shandeep and Professor Yogesh, just organizing such a wonderful and knowledgeable session. And my special thanks to Dr. Shahriar. Basically, I had also did my PhD from the UNSW and also the master. So that time I have the opportunity to meet with Shahriar, and also thanks to Katina. So I just would like to thank you both, the Katina and Shahriar, for presenting such a wonderful session, because that added my knowledge, because I did my PhD from education and I had no idea that AI has a kind of negative impact in this factor. So from this presenter's presentation, we have a kind of like a good opportunity to have the kind of thoughts and knowledge what is going on really from the artificial intelligence. So thank you, the organizers and also the presenters, for such a wonderful session and for sharing the knowledge. Thank you so much.
Most welcome.
And also just one thing to add, like if that kind of sessions are happening next time, please let us know so that we can join. So the other disciplines, we have the other background disciplines, so we can have kind of knowledge gathering opportunity. Thank you so much.
Sure. There is another hand up from Sarathi. Yes, Sarathi, what would you like to share?
Yeah, this is a very interesting topic, and artificial intelligence is in my heart. See, what happened in the cycle from 1950s to close to 80s and 90s, there was an uptake of AI and it went down. And at the same time, there are several disasters on the software that are reported or not reported. What I agree with Yogesh on that part. So basically, there is artificial intelligence on one side. Yes, it enhances the human abilities in actual problem solving. But at the same time, we need to be very cautious. These parts actually I discussed in one of the paper on systems modeling and description. I was explaining the root fundamentals of AI and the fundamentals of the computer science, how actually AI, artificial intelligence, comes into picture. It is never dealt in any of the learned materials. So basically, when we able to do a proper modeling of the systems is very much essential, and we need to segregate the software development into various categories while modeling to actually prevent error. Even today, for example, if you look at in Australia, how many systems fail? Even the coveted Australian Bureau of Statistics 4 years ago literally failed. And it said,
I think your point is taken, Sarathi, that there is obviously a need to carry out much more testing, and that is where both Professor Katina and Shahriar did mention that they need to think through the scenarios for testing and make sure that they are actually delivering the outcomes that they were designed to do. So from the design itself, or even before, from a requirements capture itself, there is obviously a need to do much more testing.
Yeah, but the other point is that the taking over the human is not, certainly we should consider, and all of people should read P.B. Shelley's Frankenstein. That's a very, very important novel. Probably everyone has heard of it. So we should see AI as a complementary role, not as a replacement role.
Point taken, Sarathi. Point taken. Thank you. Do we have time to take another question, Professor Katina and Professor Shahriar? Okay. So on the chat box, we have Ashish Vishwanath who's saying, we humans also have a lot of biases. How do these inherent biases made by AI compare against the ones made by their human counterparts?
I think Katina has answered that.
I can see in the chat box itself. Okay, great. All right, there's a long conversation. I wasn't watching the chat box because I was more intent on moderating what was happening. Right, Professor Yogesh, with your permission, shall we finish for today?
Can I just
Please.
for 1 minute? You know, this aim of this series was to actually more, you know, general awareness. So normal people, those who are in research, those who are in management, they probably are aware what is happening, but normal people are not at all aware what is happening, what AI is, what might be the consequences if they use it. So the purpose of this series was to actually make people aware some of those things that are happening and how that may impact them. And been huge interest actually in this particular series. And some of the comments I can see that saying, you know, people would be interested in more such talks. So what I would like to say that that we would continue, obviously, this series going forward. Probably not few seminar per month, but probably one seminar, monthly seminar per month going forward. So we will plan out, and from July or August, this will again continue. And everyone who's been registered, I think they will receive an email through Professor Sandeep Bhattacharya and Professor Raman that the new seminar series is going to run again. So we will keep you updated about this, and I'm sure Shahriar and Professor Katina, Michael, I'm sure they would again accept our invitation to, you know, continue giving more interesting update and you know, some more cases like this one in future as well. Thank you so much, Sir, and thank you so much, Katina, for accepting our invitation and delivering such a wonderful talk today.
And at a very late hour, it's quite late in Australia today. So, I mean, it's quite late. So thank you so much for accommodating our request just to be in the time zone of everyone, because with this timing, we can accommodate literally from the US right up through to New Zealand if needed. So that's absolutely wonderful. Great. I think we've achieved a fair amount of momentum. We've also created a large database of people who are interested, and we look forward to continuing our discussions and our engagements and possibly hosting you once again in the not too distant future. So thank you. Also, thanks to our IT team at SIBM Pune, led by Mr. Rajesh Bagewadi, for the excellent infrastructure. So we've run 15 webinars, no hitch. Touch wood, thankfully. And we also have a hardworking public relations team who creates various flyers for each event. And if you were to visit us, Professor Katina and Professor Shahriar, just as you walk off the stage, they would actually hand you a few frames, wooden frames with your photographs. But because we can't do that, I'll send those through to you by email, and you'll get that fairly soon. So thanks to our teams as well. All right.
Thank you, friends. Thank you very much.
Most welcome.
Just wanted to say that you both obviously would be most welcome to SIBM Pune and Swansea University in person when things will improve. Actually, at the moment we can't move anywhere, but I'm sure when things improve, we will have opportunity to welcome you either in SIBM Pune or in Swansea University. So we look forward to that opportunity.
Absolutely.
Thank you.
Absolutely.
We did too. Thank you.
Have a very good evening, and look forward to seeing all of you soon. Thank you, participants, for your wonderful participation. Thank you, Professor Yogesh. Look forward to seeing you soon.